Now we bring the solution to life. We'll deploy smart contracts to the private Besu network, connect applications through Ethereum-compatible libraries, and test real workflows such as asset creation, transfer, and audit review as we move toward production readiness. You've built the foundation: Besu concepts, private network design, smart contract development, and governance practices. In this module, those pieces come together as deployed infrastructure, contracts, and application logic become a working solution. A deployed Besu network becomes valuable when applications can use it safely and predictably. The smart contract holds the trusted rules, while the application layer turns those rules into APIs, user actions, or automated workflows. Transactions must be signed with the right identity and keys, then submitted through JSON-RPC or WebSocket endpoints. Integration also needs permissions, monitoring, event handling, and clear error recovery, so blockchain activity behaves like a dependable business service. Start by confirming that the contract fits the use case you are deploying. For asset tracking, it should support actions such as registering assets, transferring ownership, updating status, and viewing audit history. Check who is allowed to call each function, what parameters or dependent contracts are required, and whether deployment must happen in a specific order. Then proceed only after the contract compiles cleanly and passes development tests. Treat deployment configuration as part of the contract release. Your script needs the Besu RPC URL, including protocol, host, port, and any authentication. It must sign against the correct chain ID, or the transaction may fail or be rejected. The deployer account also needs enough native token for gas. Keep these values in environment-specific configuration files, and never hard-code private keys in source code. With the contract compiled into bytecode and constructor parameters ready, deployment can begin. A tool like Hardhat, Foundry, Truffle, Web3.js, or Ethers.js builds the deployment transaction for the Besu network. That transaction is signed with a protected key or external signer, then submitted to the validators. After consensus mines or finalizes it, the receipt confirms status, block number, and the new contract address. Finally, call a read-only function to verify the contract responds correctly. Once deployed, capture metadata as part of the release artifact. Record the contract address, ABI version, bytecode hash, transaction hash, block number, chain ID, deployer, timestamp, and constructor inputs. Store that record where teams can reliably retrieve it, such as version control, a configuration repository, or a deployment registry. This gives you traceability for audits, troubleshooting, approvals, and future upgrades, and helps prevent teams from integrating with the wrong contract. Think of the application layer as the controlled doorway into Besu. Users and enterprise systems should not talk directly to smart contracts. They should go through APIs and backend services that enforce business rules, authentication, and data handling. Read calls and submitted transactions typically use JSON-RPC, while WebSockets support event streams and near real-time updates. Keep signing and key management isolated, so blockchain access, business logic, and credentials can be secured and scaled independently. From the application, Ethers.js or Web3.js acts as the bridge to Besu. Create a provider using the RPC or WebSocket endpoint. Then load the contract ABI and deployed address, so the library knows which functions exist and where to call them. For writes, attach a signer or wallet and submit a transaction such as create asset. For reads, call functions such as get asset directly. These queries do not spend gas because they only inspect current chain state. A state-changing request is not written to the chain immediately. The application first builds a transaction with the contract call, parameters, nonce, gas settings, and chain ID. Then the transaction is signed by a wallet, private key, or signing service. Besu receives it, checks validity, shares it with peers, and includes it through consensus. Finally, the application reads the receipt. That receipt shows whether execution succeeded, reverted, or failed, so systems can respond correctly. Most applications combine two patterns. When they need the latest answer immediately, they call view functions and read contract state directly. When something important happens, the contract emits events such as asset created, asset transferred, or status updated. A listener receives those events through Besu WebSocket access or RPC polling, then updates queues, processors, databases, and dashboards. Because reconnects and retries can replay events, handlers must be idempotent, so processing the same event twice does not corrupt off-chain data. End-to-end testing should follow a real business story, not just isolated contract calls. Create an asset and confirm the data is written correctly to Besus. Transfer ownership and verify both the new owner state and the emitted events. Move the asset through statuses such as created, in transit, and received. Then test audit review by rebuilding the history from events, receipts, and metadata. This exposes gaps across the application, node, indexer, and reporting. When an integration fails, don't jump straight to the contract. Trace the request across each boundary: application call, signer, Besu node, contract execution, and final records. Confirm RPC access, chain ID, node health, and permissions. Inspect receipts, logs, events, and revert reasons. Check balance, nonce, gas, and signer configuration. Then compare the expected business result with on-chain state and off-chain data. This layered approach turns troubleshooting into evidence, not guesswork. After the application goes live, the contract is only one part of the system. Operations must prove that the whole integration is healthy. Track transaction success, confirmation delays, node availability, and listener failures. Protect signing keys with vaults or manage signing services, never ad hoc storage. Build resilience with retries, idempotent processing, logs, and alerts. Keep environments strictly separated so testing, releases, and production activity remain controlled, traceable, and auditable. You've now taken a private Besu network from deployment to application behavior. Contracts deployed securely, applications connected through managed RPC and WebSocket access, workflows executed, events captured, and outcomes validated end-to-end. Next, we shift from "it works" to "is it production ready for enterprise operations?"